Good morning, everyone. Welcome to a reasonably short session. Reasonably short, I hear you say. That's not normal for one of mine, but I'm going to try and keep this one reasonably short. It's a nice, interesting subject, but it shouldn't take too long to actually discuss it. What we're going to cover is snapshots. We're going to talk about what they are and definitely what they are not, because I think there's sometimes a bit of confusion about that. So let's actually do that first, a bit of theory. So LVM snapshot creation, to create them is a simple LV create command, very similar to the ones we've been using up to now. -- snapshot, specify a size, so you just create a snapshot which you feel is at least big enough to cater for whatever changes you're protecting yourself against. And then give it a name, -- name, root_snap, because I want to snapshot my root volume, which is a classic. So you're going to do some updates, or in our case, we're going to install an application, and you want to protect yourself in case it all goes horribly wrong. So if it's going to install in the root volume, which is really critical volume, isn't it? You know, if you lose that, you can't reboot, or if it gets broken in some way. So that's, and then finally you have to actually say, what is it that you want to snap? So we're saying I want to create a 10 gigabyte snapshot whose name is root_snap, and it is a snapshot of the Ubuntu LV, which is the root volume. I've chosen the root volume because the root volume is very slightly more complicated to recover from. Creation of snaps is the same for everything, but it's slightly more complicated to recover from than a regular volume, and we will explain why in a minute. So first of all, let's have a look at what they are. And the first thing we should say categorically, a snapshot is not a backup of any size or description. A snapshot allows you to return to a previous state. However, as we'll see, we are not making a copy of the current state. What we're actually doing is making a copy of the changes that have occurred to the current state. Okay, so we're going to do a root volume. So you can see there with my another one of my wonderful diagrams, we've got our root volume, which is going to be known as the origin. So the origin is, where is this snapshot come from? And we create a snapshot volume, and you'll notice when we create it, it's almost instant. It's snap, we've got a snapshot volume. Why is that? Because it's completely empty when you create it. Okay, so you've got some data in the queue, you've created a snapshot, you've got some data in the queue, it's going to get written to the root volume. All right, so that's where we are at the moment. So the first thing we've got to do is copy the old data, or the original data, onto the snapshot, okay, because it's going to get overwritten. So the snapshot, you now see, if you didn't know this already, the snapshot doesn't contain a copy of the state of the root volume now. It contains any changes that occur to the root volume. So first thing we do is copy the data across, and then the next thing we can do is the write, and this process is known as copy on write, or COW. No, I prefer copy on write. So now if you look at it, we've got the root volume, which is up to date. So the root volume is exactly as it should be. However, we do have the old data that was there. So straight away you can see the principle here. If we've got the old data, we can copy the old data back onto the root volume, and everyone lived happily ever after. So it's like a fairy tale. Right, so now that's the state we're in. We've got the root volume, we've got the new, it's called the origin, remember, but we've got its state is as it should be. Okay, it's bang up to date. Our snapshot has copies of any data that changed from the moment it was created. So in the event that we need to roll back, it's really straightforward. We have the original data on the snapshot volume, so basically we copy it back, overwriting the new data, and at that point the snapshot volume will also be deleted. So we end up where we started, okay, which is another reason why this is not a backup. You can't say, oh, I edited a file and changed something in a file, I want that file back, or I want to undo the change to that file. Nope, it's all or nothing. You can go back to a point in time, but you can't extract bits of information from your snapshot. And the reason is the snapshot volume does not contain structured data. It doesn't create. It doesn't. If you change a file, it doesn't copy the original file across the snapshot volume. It only copies the block that was changed. So there's no context. So you can't. It's all or nothing. You either roll back or you stay where you are. Now, if we make this major change, we've created the snapshot to be on the safe side, and we then decide everything's wonderful, not a problem, this new change is actually what I want, then you simply do an LV removed and you delete the snapshot volume. Of course, at this point we can't now roll back, but that's okay, you've made that decision. Okay. And the actual commands involved, and this is more complicated because I'm talking about the root volume. You do an LV convert -- merge. So the terminology is we don't roll back, we merge. Okay, so we merge the snapshot into the original volume to get back to where we were. Now the root with an ordinary volume, you had to unmount it to do that, by the way. So you have to if you've done a snapshot of a regular volume. You have to unmount it first, then roll back or merge. Then when you remount it, everything's wonderful. That's fine. But with the root volume, we can't unmount it. Okay, so you do your LV convert -- merge, and it effectively is scheduled. You know, the merge is if you want scheduled. So you have to reboot, and when you reboot, the root volume will then be back to where it was, which is fine. But then you need to activate it. So you do an LV change -- activate Y. So you only need to do that on the root volume. And ridiculous as it sounds, that's it. That's how easy it is, which is what we're going to do now. So let's actually get on and do this in practice. What I plan to do, by the way, is do something I never ever do, and that's install a desktop manager, a Windows environment. Okay, so what we're going to do is first of all do a snapshot so we can recover back to a safe point in time. Then we're going to install Ubuntu desktop environment, which is quite big actually, and most production environments and most servers don't install a desktop for a number of reasons. I mean, one of which is you don't normally have a console connected to your servers in a server room somewhere. But the other one is you're increasing the attack surface, because desktop environment probably takes 3, 4, I'm not entirely sure actually, we'll find out in a minute, but it'll take quite a few gigabytes on top of what we currently are. So let's see what we currently are. Do a df-h of root, and we are 6.2 gigabytes. So currently it's 6.2 gigabytes. And what we need to do first then is create a snapshot. Now, we have to decide how big that snapshot should be. So the first question is, do we have any free space in our volume group? So if we do a VGS, that actually tells us that we've got 54.37 gigabytes free in our volume group called Ubuntu-VG. If we do an LVS, just to see what volumes we've got an Ubuntu-LV. That is our root volume. It is the only volume, actually. So what we need to do is snapshot that. So how big should we make our snapshot? Well, we've got 54 gig. Let's make it 10 gig, and then we're more than covered in terms of space. We need to say that this is a snapshot. We need to give it a name. And we need to say what is it exactly we want to snapshot. So we're saying, give me a snapshot of 10 gigabytes called root snap, and it's a snapshot of Ubuntu LV, which is in the volume group Ubuntu VG. And it's created it instantly, and why is that? Well, we know, because it's completely empty. Okay. So having created our snapshot, what we now need to do, I'll try speaking English, we're going to do an apt install. Now, I happen to know that what we want to install is Ubuntu GNOME Desktop. I know that's the name of a group. That's like a package group that will actually install loads and loads of packages. So what if you didn't know? So you could do an apt search GNOME-desktop. Okay, now it isn't actually called that, but it's called something like that. And if we look here, well, in fact, there we go. As it happens, it's at the bottom. It's Ubuntu-GNOME-desktop, the Ubuntu desktop system. Or we could install a vanilla GNOME desktop, which I presume the Ubuntu one is branded for Ubuntu and the vanilla one is presumably not. We'll put in the Ubuntu one. Let's go along with that. So we'll say apt install Ubuntu, GNOME. I'm just going to say -y. This will take time. So I will do some editing. This will probably take quite a few minutes, so I'll do some editing to try and not bore you to death watching the screen go up. All right, that finally finished. It took forever. There were a couple of errors to do with speech capture or something, but this machine hasn't got a microphone or anything on it, so that's probably why. I don't even care, to be honest. I'd research it if I really cared, but I just wanted to install the desktop to show you. So let's now do an LVS of Ubuntu-VG and see what we've got. All right, so if we look, a few things here. The root snap, we've got the S in the attribute first field, which is what type of volume is this, so it's a snapshot. This tells us how much of it we've used, 47%, so it's very nearly 5 gig. In other words, installing a desktop environment, it's very nearly doubled the install size. Now notice that the Ubuntu volume has an O in the type, and the O in the type indicates that this is an origin. One thing we should do, systemctl get-default, find out whether, because I've got a feeling it doesn't automatically set it to run in graphical mode. Oh, it has done. Okay, so systemctl get-default shows me that it's a graphical target. If it hadn't been, by the way, I would have simply done this. I would have said set default, and I could choose, for instance, not graphical, which would be multi-user target, or graphical, which is obviously what we want for our test. So I'm going to hit enter. I'm not sure if you need to reboot, but I definitely saw it said it was rebuilding the kernel zipped file, so we will reboot anyway. And to do that, actually, if I can show you, I've got HDMI capture on it. Hey, looking good. So we have successfully installed a desktop manager. So let's log in. Right, so we want a terminal. Text will be a little bit small, but I'll expand it. Right, so first let's do a couple of things just to see where we are. Let's remind ourselves LVS. Let's remind ourselves of the current state of affairs. Notice that the snapshot has an S indicating this is a snapshot, and the Ubuntu-LV has an O indicating this is the origin. Let's do a df-h of root and see how much space it took. It's used 9.9 gig, so that's 10 gig, so it was 6 gig, so it's used about 4 gig. That's just totally ridiculous, but there you go. So now let's merge it back, lv convert, --merge, then we have to tell it what do we want to merge, _snap, hit return, and it says delaying the merge since the origin is open, and this is what I've mentioned a couple of times. This is because you cannot unmount the root volume. Now if this was not the root volume, that would simply work. This requires us to reboot, right, but we have successfully merged it. But if we do a df-h, you can see that it hasn't actually done anything yet. You're still using 9.9 gigabytes. Okay, so we've proved that we've installed the Windows successfully, desktop, Ubuntu desktop successfully, GNOME. What we now need, and we've merged them back, which I did in the window environment, but to be honest, I don't think it was very clear. I could have done it in this terminal, which I'm hoping is clearer. So let's do a reboot, and now we should be back to where we were before. So let's become root. Let's clear the screen. Let's first of all do an LVS. And what we should find is that the snapshot has disappeared. We have a capital O for origin, all right, where the origin originally was. The little o simply means I am the origin of a snapshot, and the capital O means there's a merge in process. So we need to, as it were, complete that merge. So we now have to do an LV change, and we have to activate the volume. We can, by the way, you know, all these commands have got abbreviations. I always put them in full, but you could put -a there, and you say LV change minus activate yes, effectively. Okay, and it says it doesn't recognize. Oh, silly boy. Okay, so now when we do an LVS, everything is back to normal, and it looks wonderful. And if we do an system ctl get -defaults, then it tells us, oh, it still says graphical target. That's interesting. Maybe it says that. Maybe it's just set to that by default. But obviously, if you don't have a desktop environment installed, it can't run a graphical environment. So let's just say set -default, and let's put it to multi-user, which is non-graphical. Okay, so set system default to multi-user target. Now if we do the gret, and all it does is creates a symlink to the correct target. Okay, and there you go. That is snapshots. It really is that simple. Well, I hope you found that interesting, and you are now familiar with Ubuntu Logical Volume Manager snapshots, but it's the same on different distributions as long as you're running Logical Volume Manager, of course. So that's all for this session. I hope you enjoyed it. Please do subscribe and like, etc., etc. And I hope to see you shortly with yet another exciting episode in our saga. Cheers, everyone.